Have to introduce them today. They're going to be doing 3 epic talks. So I am very pleased to introduce DanStolts and IanPhillpot. They're going to be covering design and management, monitoring, and business continuity strategies. So please put your hands together for them.
Thank you. I'm Dan Stoltz, Chief Technology Strategist for Microsoft. Most important thing, you can reach me on Twitter at ITProGuru. Socialize, right? Let's get the word out there. And this topic is actually like a 2-day topic that we're going to cram into 75 minutes or more. I'm thrilled to have Ian,
Hi.
my partner from Atlanta. And why don't you introduce yourself?
I'm IanPhillpot. You can find me online at tripdubroot, and that's basically triple W root folder from IIS, right? Okay, so it's kind of geeky. I'm a TE, along with Dan. I'm his counterpart in Atlanta, kind of the dev to his ops. We both do DevOps, and I kind of approach it from the developer's perspective, and he reins me in from the ops perspective. So I think we should just get moving.
Yeah, I agree.
Yeah.
I agree, and that's a good analogy, reining you in. You know, that's what IT is always doing, is reining in the developers.
So we'll run through this pretty quickly. I'm going to go over the monitoring strategy as well as Azure Automation. And Dan is going to talk to you about business continuity and disaster recovery. So we're going to just run right through it. Like he said, this is like 3 days worth of content in 75 minutes. So we're both going to go into our hyperspeed talking voices and go really quick. Okay?
It's recording though, right?
Right.
So you'll be able to get to it later. Plus, we have the slides available online. The slides that we're presenting are not the same ones that are online. I'll have them up there today, before the end of the day.
Yep. All right. So we're going to basically talk about the System Center suite of products. We're going to talk about Configuration Manager, which is exactly what it sounds like. It's used to configure things. Operations Manager is around monitoring, and that's where I'm going to spend a little bit of my time. Dan's going to talk to you a little bit about the VMM, Service Manager, Data Protection Manager, and Orchestrator. So we'll hold those till we get to that port. We're also going to talk about the built-in capabilities coming out of the Azure portal, Global Services Monitor, Application Insights, and Operations Management Suite. I'm going to define those in each section, so we'll get to that. Now, one thing as you're coming into this particular test is you're using architectural skills to do this test. So I put a nice little link right here that describes kind of the overall view that Microsoft has when it comes to monitoring strategy. You have your data sources, and these data sources could be anything from a particular framework to an operating system to an application that you've built or a third party has built, even infrastructure logs like network router logs and things like that. These are all potential things that you're going to be monitoring. You're going to ship that up and collect that in some sort of storage location. Typically in Azure, one of the things we're going to be talking a lot about is Azure, Azure storage. The next thing there, of course, is analysis and diagnostics. We're going to look at how SCOM is that single pane of glass that gives you the ability to do some of that diagnosis. And then, of course, we need the visualization with tools like, again, SCOM, some of the Azure portal, and, of course, like Power BI and other things like that. So let's go ahead and jump to the next slide there. And talk about Global Services Manager. You probably won't see this a lot on the test. There'll be maybe a couple of questions, but it's good to know what it is and what it does. Essentially, it allows you to configure web applications, or excuse me, to monitor web applications. And you're going to use data centers around the globe to actually monitor maybe a web app that's running in the US. And the key point here is that if you want to understand the user experience from Australia to a website that you have running in the US, then this is a great tool to do that, because you can set up synthetic transactions and run them from any one of our 40 data centers around the globe against that application and see the metrics and things of that nature. So I'm going to go with that and say that's probably good for the monitor there. The next piece here is a very important one. We'll point this out because we've probably pointed this tool out in like 4 different modules today, or between yesterday and today. So you can guarantee you're going to see that amount of questions on the test. also in the real world that it is that important to use this product when you're working with Azure. Now, I like to focus on application insights as an application-based tool. It can, without any code, monitor both the JRE as well as the .NET framework, the .NET runtimes. You can also, just with a single line of code, new up instances of Node, Express apps, that sort of thing, with literally like an NPM package in one line of code. You're up and running. Same thing with .NET Core and stuff like that. You can just drop one line of code in, and you've got your application insights collecting basic metrics about that application itself. You can then go on to add telemetry and instrumentation in different parts of the application so that you can collect how long something takes to execute within the application and ship that off with just a little bit more code, but you do have to write that. You get alerts through email or webhooks from application insights. Then you can also kind of use this to dive deeper into what's happening and drill in to different reports and things that you get exposed right out of the box. One of the newer features that you're going to have is live application monitoring. So if you enable that within the application, you have a pane of glass where it's just scrolling through, and you see your hit counters and things of that nature scrolling. So know that that's available. Also know that it does track dependency responses. So if you're using a third-party web API or a SQL server in Azure or whatnot, it will give you response times for those requests that are made to that particular thing. Now, Operations Management Suite is a great tool. It's a newer tool that has been expanded. Originally, you were just looking at log analytics, and essentially what happens is you have an Azure virtual machine, and I'll talk a little bit more about this later. It has a VM agent that can ship those logs off to storage. And log analytics can hook into that process and pull that data into OMS and give you kind of that single pane of glass to start looking at that. Now, Azure Automation also has a standalone version of Azure Automation and an OMS version of Azure Automation. Basically the same thing, except that the OMS version is enabled so that you can, based on telemetry information coming out of log analytics, you could run a runbook that's in that version of Azure Automation. Same thing, still works with runbooks, it's just part of OMS. Dan's going to talk to disaster recovery a lot more. Just know that you can roll this data up into OMS dashboards and understand what's going on within your backup and site recovery processes. Bill yesterday showed you about the security center and security and compliance types of things. Again, you can new those types of information up, and instead of reporting them in multiple locations, you can pull that data into OMS and report on it in one location. So just know that these are available and what they do. System Center for Azure. This is SCOM, right? So if you have a hybrid deployment or just already an on-premise deployment of SCOM, you might want to look to SCOM to actually monitor not only on-premise, but also your Azure subscription and resources running in that Azure subscription. Remember, as with what we're going to talk about with patching, you pay for egress, right? You pay for egress. So how you build this could have bandwidth costs. Also, I think the smallest size for running a SCOM instance is like a D1 or D2 within that. So you're going to have VM costs because this would be, I'm going to build 3 virtual machines, and it takes 3 virtual machines to run SCOM, and they're all D3, that's $400, that's $1,500 a month. So just know, as you're architecting these types of solutions, that is a cost. Now, if you don't want to do that and you want to run it on-prem, typically for the test, you're going to default to running on-prem and monitoring Azure. Now, that's not necessarily the case when you get one of those scenario-based questions. That's not necessarily the case, but it's probably a good thought that actually you're going to run the SCOM on-premise and somehow manage Azure. Now, how would you do that? You would use site-to-site VPN or ExpressRoute. Site-to-site VPN uses your virtual appliance, or your VPN appliance on-premise and talks to the VNet VPN gateway, right? So you set up the keys between them, and it establishes that secure connection. But it's more like a branch office type of scenario, whereas ExpressRoute actually brings in the VNet into your MPLS cloud, right? So it kind of becomes part of your routed network, essentially, which is pretty cool and can enable some things. If you don't use either one of those, you can use the gateway server. So know that these are the options for how do you get data into or out of SCOM with an Azure subscription. You can have a gateway server. Gateway server basically uses X509 certificates to secure a TLS endpoint between your SCOM on-premise and a gateway sitting in a VNet up there. And basically the agents sitting in the Azure VNet are pointed to that gateway server. That gateway server does the data collection and ships that down to your, securely down to your on-premise SCOM full-blown environment. So that's kind of the idea there. Also know that you might get some questions, and something you would have to think about in the real world is, are these machines domain joined? And if they're not, are you using certificate-based authentication to actually authenticate between SCOM and those non-domain joined machines? So that's another scenario that you might see when coming into this. To actually monitor, there's an Azure Management Pack. I would highly recommend you go download the Management Pack user guide, right? So just go to download Azure Management Pack, click the download button, and it'll pop up and ask you if you want to download the Management Pack and the doc, or just the doc. You can just download the doc, open it up, and take a look at it, because it does give you some good information about what it will monitor. And this is pulled directly from that. This you want to know, what it can go out and auto-discover, and based on what it can auto-discover, what it can actually pull performance information on. Okay? So you don't actually need to memorize it, but be familiar with this, because you may get some questions around that. Yes? I don't know. We'd have to look offline and take a look at that. Good question. Azure monitoring strategies. Okay, so we've kind of talked about like actual tooling that you can use between Applications Insight, Global Services Monitor, and SCOM. But what does Azure actually offer kind of out of the box? Now, all those things we just talked about are great for collecting historical data and looking at kind of that point in time. Now, with Azure, you have the portal, and it provides a couple of panes of glass when you go to web apps or when you go to virtual machines, and you can look up CPU information and stuff like that if you enable diagnostic monitoring. If you do that, you can set up all kinds of performance counters and stuff on a dashboard in your portal so you can see that. But these are good for point-in-time types of information. This isn't good for, hey, what's happened in the last 6 months with this server. This is, hey, what's happened in the past hour, right? These are good for that. So you can go into the portal. You want to understand the capabilities of that. The lab walks you through setting up alerts, which you can also do, which are very handy in a pinch. You can go in and say, hey, if my CPU hits over 80%, send me an email or call this webhook. And that webhook could be a runbook that executes and scales out your VM infrastructure, your scale set or something like that. Okay? So just know that that's there. Also, I've linked to all of the SLAs. So we have a summary of all the SLAs. You want to know the SQL SLAs, you want to know the VM SLAs, and you want to know the web apps SLAs. Those are the ones that you definitely want to know. The other ones, like Azure AD and stuff like that, you want to be familiar with. But basically, it's all 3 nines or 9995, right? So just know what that means. VM monitoring, very similar to what I just talked about with the portal. You basically go in, you click Enable, and you tell it, hey, store the logs in this storage account, or in blob or table storage. So you have a couple of options there. And by doing that, that enables all of this storage for SCOM and the management pack. Enabling this diagnostic monitoring is crucial to lighting all of that up. Now, the key here that you may see on the test is that there is a VM agent installed both on Linux images as well as Windows images within the within Azure. If you bring your own image, whether it's Linux or Windows, you need to have that VM image installed to enable diagnostics so that Azure can pull that data off, or to be able to like reset and manage, if you lose the machine, be able to reset it through the portal and stuff, you need to have this VM installed. If you don't care about being able to manage it, then you don't need the VM agent installed. It's a very small footprint, so don't worry about it. Know what that agent will ship, what types of logs. It's basically the event logs and diagnostic logs. Also, an important part to this test, they will talk about patching. Know the cumulative update patching cycle for Windows. So there's 3. There's the monthly roll-up, which includes all patches for that product. Previous months included, not just this last month, it's all months. Security only or .NET Framework. So if you don't want all the patches, you can just do the security only, which gives you just the last month's security updates. Or you can do the .NET Framework update, which is just the last month. So know the differences between those and understand that. I got links to that in there. Windows update services here, SUS servers, or WSUS, whatever you want to call it. It used to be called SUS. I still run with SUS. Is our ability, gives you the ability to approve and host the Windows updates. And you can set up groups, and I can approve the updates for a set, like 10% of my servers. And these are my my beta testers for these updates. And if everything looks good on those sets of servers, then I can go out to larger groups of my servers or whatnot. A couple of key points here to understand is that you pay, again, for data egress charges. So if you set up a SUS server in Azure and you're like, oh, this is great, I'm going to set all my clients, all 10,000 of my clients, to go out to that SUS server and download updates every month. Thank you. I appreciate that. I want to work on your account. No, you can set this for approvals only, right? So you can go in and say, I will approve this roll-up for these machines. And all it does is approve that. It does not actually download from that SUS server. It goes out to Windows Updates and downloads from Windows Updates, as you would imagine. So you don't incur that egress. So know that that is available and expect that kind of thing on the test around that. Configuration Manager, for a test perspective, it's kind of geared towards client operating systems, not necessarily a great thing for server operating systems. But the key point here is that you get third-party updates from it. And it requires SUS server. Okay, so just know those kind of couple of informations there. You won't see this on the test most likely, but I did want to drop this in there, is that there is a patching extension for Linux that's supported by Microsoft, and it's out there on our GitHub. So you just execute this against the virtual machine whenever you want to patch it, and you can do, apt-get update and run all that, whatever your kind of script you want to run. When it comes to patching, you're going to be bouncing servers and rebooting them and stuff. So as we're thinking about this, we also need to think about availability sets, which include fault domains and update domains. Fault domains are basically single points of failures. So if I take 2 servers of the same machine and I put them in an availability set in the same fault domain, and I lose that switch's network, the rack's switch, I lose both of those machines. I don't get that 99.95 SLA if I do that. I have to have 2 machines in separate fault domains because that puts them in different stamps within the data center. So if I lose that rack switch, it doesn't take down my other VM. Easy enough. Update domains, we do rolling updates for the underlying Hyper-V infrastructure within Azure, and we'll reboot this rack. So if they're in the same update domain, we could reboot that machine and you could lose both machines. So this is around like Azure updates. So drop those out into different update domains as well as in different fault domains, and you get that 99.95. So understand those for the test. And I'll turn this over to Dan.
Thanks, Ian. And thanks, everybody. One thing I wanted to mention as we roll into the part 2, Ian will definitely be back, but the content that I'm going to be delivering, I had Kevin's name on the first slide, KevinHillinger. I really want to give him a ton of credit, though, because on my slides he did an awesome job of taking the content that I had and making it beautiful. So tip my hat to Kevin for an awesome job with doing the slides. Let's start with architectural capabilities of BCDR. It really is on 3 different pillars. You've got high availability, you've got disaster recovery, and you've got backup. If you look at this from the standpoint of from a primary site standpoint, if my entire server, my entire rack goes down, I have high availability, so I've got another copy of it already running, so I don't lose any service. Disaster recovery is my primary site goes down, then I have a secondary site that is up and running in short order. When we talk about backup, it is I've lost data or data is corrupted, and I have a copy of that so that I can restore it very quickly. A couple terms that you want to make sure that you know. Super, super, super important. So if you're asleep, please wake up now. You will see this on the exam. I promise you. You will see this on the exam. RPO, RTO, you need to know what they are. RPO is recovery point objective. RTO is recover time objective. And RPO is I'm going to actually read it because I spent a lot of time figuring out how to word this in a way that it would make the most sense. If you look up the terms and stuff on Azure, I just don't think they did a great job of making it clear. So hopefully I did a better job. RPO is the maximum targeted time that data can be lost in time. It is the amount of time between backup, replication, or synchronization. It answers the question, what is an acceptable amount of data loss? Again, it's in time. Can I lose 5 minutes? Can I lose 5 hours? Can I lose 5 seconds? If the answer is no, obviously you've got to put things in place to account for those answers. And it is usually much smaller than RTO. So what is RTO? RTO is how long it takes in time to restore services after a disaster. It answers the question, how long will it take to get my services back online? So I like kind of the questions that it answers as a way of kind of memorizing what they are. You will need to know both of these terms for the exam, I promise you. More importantly, you will need to understand these terms and what they measure because as an architect, they're super important. With that, I'm going to pause for a second and tell you this. The architecture exam and becoming an architect, a cloud architect, in our organizations is much more than understanding the products that we're dealing with. So Ian talked to you about a few things, like monitoring capabilities. Well, why do we need to know that? Application insights. Why do we as an architect, we're not the welders out there working on the bridge, right? Why do we need to know that? Well, if there's a problem with the bridge, who are they going to call? Are they going to call the welder? No, they're going to call the architect, right? So you need to understand how all this works. You need to know the tools that are available to you so you can architect those as part of your solution to keep these numbers where they need to be. Architectural capabilities of BCDR, recovery point objective and recovery time objective, they're drivers of the cost solution. They talk about the minimal data loss as well as reduce your downtime. So how long can it be down before I have to bring it back up? How much data am I going to lose in that process? And the reason why they're drivers of cost is because as you want to reduce your RPO, you are going to pay for it, right? Because if I can be down for 10 hours, then it's not nearly as expensive as if I can only be down for 3 minutes, right? Huge difference in cost between those scenarios. So as an architect, we need to understand what those things are and plan for them. Availability, storage, redundancy, and SLAs. We have to know all of these things. And I'm not going to go into any detail on these because we've talked about it in lots of other sessions. By the way, lots of other sessions mean if you hear the same thing in multiple sessions, the likelihood it's going to be on the test goes way, way, way up. Because that means that question is on multiple sections of the exam. You might even hit it twice. I'll tell you, when I took the exam, it's been a while, but fault domains, I got the same question twice because it was in 2 different groups, right? So that can happen, which is great if you get it right. Not so great if you don't get it right. Network connectivity, application connectivity, post failover, IP management, load balancers. How does all that work? Right? You have to plan on those capabilities. So let's talk about what is business continuity and disaster recovery and how they work together or not. So I'm going to actually start on the right-hand side of the slide here. When we're talking about disaster recovery is a subset of business continuity. Disaster recovery says, I've had a loss, a critical loss, some kind of loss, now I got to get my services back up and running. That's disaster recovery. You're recovering from a disaster. Business continuity is, I am planning so that if there is a disaster, I don't lose my business. But it's so much more than that. So business continuity is much, much, much more than disaster recovery. And disaster recovery is a piece of business continuity. So let me give you one example of how they diverge, right? Business continuity is the plan of how we're going to keep the disaster from happening and then how to recover from it. The disaster could not just impact technology. It could be people, right? If you've got, who's read the book, The Phoenix Project? Anybody? A few people, okay? There's a character in the book that's Brent, and he is the guy that everybody comes to whenever there's a problem. They don't know how to solve it. He's the guy that has all the answers in his head, right? Everything revolves around him. If they lose him, oh my God, what's the business going to do kind of scenario, right? And in that case, Brent, in this case, would be part of the disaster recovery, part of the business continuity plan. What happens if we lose Brent, right? So you have to start cross-training and getting other people skilled up to be able to do Brent's job in that scenario. So that's just one example of how technology is not the only thing on the business continuity plan. And the cost to businesses for not doing business continuity and disaster recovery can be catastrophic. This is something that has put many, 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 many businesses out of business. So keep that in mind. And even those that it hasn't put out of business, it's cost them dearly. Like, these are CEO events often, most of the time, something like that. And especially if you don't have a plan, they're almost always a CEO event, something that goes to the CEO or goes to the board because it's a major thing. I don't want to give names, but you've heard in the news about some of the real disasters that not necessarily related to nature, whether it be hackers or anything else. You have to have a plan for being able to deal with things as they come up. Exam tip. And by the way, you're going to need to read through all the exam tips for not only my session, not only our session, but also all of the sessions before you go take the exam. Just spend an extra hour, go through and read all the green pages. And asynchronous operation is one that transpires sequentially. First one action, then the other. Okay? Synchronous means the operations are carried out at the same time. Think of it as parallel processing. I'm doing both things all at once. So let's talk a little bit about Hyper-V Replica. These terms you will need to know. I almost guarantee you they're going to be on the exam. Even though this is the only session you might have heard it, you can count on it. This is almost a fourth of the exam is on this session that you're hearing now. You can guarantee that's going to be on there. Hyper-V Replica. Hyper-V Replica, and you can go back and read these slides later. Well, they'll be made available online. Hyper-V Replica is a piece that gives you it runs on Hyper-V and allows you the capability of replicating a VM from one location to another. And it uses asynchronous replication. It's replicated per VM, and it's over HTTP. So it supports planned failovers, test failovers, unplanned failovers. No shared storage is required. The systems don't have to be on shared storage. That's part of the technology that Microsoft introduced a number of years ago to do things like remapping storage, okay, and moving storage, replicating storage. So when not to use Hyper-V Replica. Workloads requires synchronous replication. Remember, this is asynchronous. One and then the other. And then data is outside the VHD, because it's not, Hyper-V Replica doesn't protect that data that's outside the VHD. The workload needs to recover physical servers. So remember, these are virtual machines, not physical hosts. A little deeper on Hyper-V Replica. It's a role in Hyper-V. It was created, started in Windows Server 2012, and it's been available ever since. You do need to have sufficient storage at the primary and the replica sites to host the virtual machines, because you're taking an exact copy of that virtual machine and you're copying it into the replica. Or if you have replica, into another rack or another data center, or into Azure or wherever it's going, you need to have the exact same amount of storage. Network connectivity between the primary and replica sites. You need to consider that. How much bandwidth do you have, and how long is it going to take to change data? If you've got a whole lot of data that's changing in the VM, it's especially important. Okay? Properly configured firewall rules to permit it. And you can authenticate with mutual authentication with certificates, but it's not required. So it's a great way to kind of do authentication in the background. Use cases, primarily for disaster recovery and business continuity. Right? You can use it for other things, though. Site-to-site cross-replication protection. Host failure within a site. Right? If I have a problem on, so like if I just want to be able to get that server back up and running quickly, right? My time to recover needs to be under 5 minutes. Well, you can't do that unless you're replicating that entire server, right? You can't restore from tape in 5 minutes. So that's when you would need something like that. Migration mechanism to move things to the cloud, right? People don't often think of that, but absolutely you can just enable replication, start the replication. Once it gets to the cloud, fail it over, boom, done. It takes care of all the networking and mapping and all that stuff for you. So good use cases. Azure Site Recovery. Think of this as an extension to or another enhancement to Hyper-V Replica. I'm going to try to take the question, but I'm probably going to have to skip. Go on. So the question, thank you. So the question is, whenever you're replicating to the cloud using replication or Azure Site Recovery, how do you deal with availability sets and making sure that your availability sets are in line so you do have multiple copies of your database? First of all, if you're going to have multiple copies of your server, if you're going to have multiple copies of your server, those are just going to go into different availability sets whenever you're also going to, because you're doing it at a VM level, you're not doing it at a host level or a cluster level, you're doing it at a VM level. So at the VM level, one version of that is going to go to one fault domain. The second version of that is going to go to another fault domain. That is your high availability. So a few more things on Azure Site Recovery. Gen 2 to Gen 1. If you have Hyper-V on running Gen 2, it'll automatically do that conversion for you because we don't have Gen 2 machines in Azure. So you can push the install for ASR, remote WMI, and file and print sharing. So lots of different capabilities in there. You do have replication for on-premises VMware VMs, Hyper-V VMs, Windows and Linux physical servers. So Azure Site Recovery Support Matrix. This is not green because I don't think you need to really remember this chart, but it would do you well to kind of look through it and understand it. What the support is. OS is supported for Azure Site Recovery, and BCDR capabilities, use cases. And really on this slide, I wanted to kind of compare the two or look at them from a different contrast. Simple, affordable, second site, extended replication to third-party with third-party integration, hardware agnostic, either side. From the hybrid cloud standpoint, seamless integration, private cloud or on-premises, service provider cloud, Microsoft Azure. From an Azure Site Recovery standpoint, use the second site, or if you're using SCCM or SCVMM, if you're using the System Center products, and you have otherwise unprotected workloads. When not to use, when the workload requires synchronous replication or data outside the VM, we talked about that. A little bit further, I'm not going to read through all of these or have you study it, but I do think it would be wise to, I do think it would be wise to look through this and kind of understand the different capabilities and use cases for the different products, whether it be System Center, Azure Backup Server, or Store Simple. And just really what you want to hone in on is what the differences are, right, for the test. For being an architect, you kind of need to know what the capabilities are. So depending on what you're studying for, you'll need to know that. So some of the things I would look at this is Azure Backup Server. Think of that as DPM as a service, right? So that's your full-blown capabilities, including tape backup as a service. System Center Data Protection Manager, your on-prem, has everything, backs up your SharePoint, your SQL, your Exchange, all of that stuff. And then Store Simple is a device that you run that has a huge cache built into it. Think of it as like a SAN almost, with a lot of intelligence that scales out to the cloud. So you can use the cloud for your cold data and use hot and warm data to stay on-prem in that device. And then Azure Backup is a cloud-based solution for just backup. Some exam tips, you'll want to know some of these, you'll at least want to be familiar with. You don't need to memorize them, but these you want to at least read through once or twice. Sharding is when you take a database and you partition it out. Has anybody talked about sharding yet? Okay, so sharding is when you split a database into, or really even a table, it could be at any level. You're splitting it out into multiple parts. So like if you have a database of customers, or a table of customers, you can literally split it at the table level. So A through D goes to this shard, E through G goes to this shard, and every time you split it, you're going to different platters. So you exponentially increase performance by sharding out a database. So it's really designed for super large databases, or if you need ultra high performance out of your database, then you could use sharding. There may or may not be any questions on the on the exam, but I did want you to just kind of read over it just in case. It's an easy, free question if you know what it is. Data Protection Manager and Azure Backup. Big difference between the two is the SQL Exchange SharePoint extensions, as well as direct VM. So Hyper-V VM machines can be backed up on DPM. So it'll back up, DPM will back up more workloads. DPM is deployed on-premise. And DPM can also, DPM stands for System Center Data Protection Manager. And the different requirements. So I would read through these and kind of have a familiarity with the differences between those. DPM architecture looks kind of like this. You have all your different workloads that you're protecting, like I said, Hyper-V, SharePoint, SQL, etc. And then they go into your DPM server. From there, it writes to disk storage. It can also write to tape. From tape, it can go to offsite storage. From this disk store, it can also be replicated to other sites or replicated to Azure. So read and practice a couple of these things. Backup. I kind of emphasize backup a lot in this because whenever I took the exam, there was a lot of stuff on it. Based on the way that I hear that they've changed things, I'm not quite so certain that it requires that much in-depth knowledge. But you definitely want to know things like scheduling and what different types of workload. Why do you need to know that as an architect? Because why spend the money and the time and the energy for DPM if what you can get for much less is available in Azure Backup? If you don't need management, as an example. If you need management, then you got to go up to the higher tiered systems. But it's important to understand those differences so you know what you're going to architect as part of your backup strategy. How it works, I'm going to just go and flip through this. You do have to install a backup, Azure Backup software on the client, and you can do the authentication, lay down the certificate, and then start scheduling. Exam tip, Mars Agent Installer, that's the name of the executable for the backup agent. That was on my exam. I don't know why, but it was. And the Web Admin MSC, so the application itself is actually an MSC. It's not a separate executable that you're running. And the maximum rate of backups per day is 3 times a day. So on your schedule, the maximum times you can schedule a backup is 3 times a day. So like if you want to do it every 8 hours, that would be fine. If you want to do it every 4 hours, well, you're going to get 3 for 4 hours and you can't get any more because you only have 3 slots. And you'll see that in the schedule when you go look at it. This is a backup schedule as well as the retention policy screenshots. The big things you'll want to know about this is where your limits are, right? How many backups? How many years can you do backup? How many times a day can you do a backup? Those limits are the things that are going to hit you. So just kind of read through those and kind of understand what that is. So you can cancel a schedule and remove backups, but you do have to go into Azure to get a key. It's not like anybody can do that. You've got to go into Azure to get the key. So you have to be able to do that management to get the key to then put in the key to actually remove that. A lot more information on Azure Backup Server. Remember, Azure Backup Server gives you a lot of the capabilities of DPM, but it's more of a cloud kind of solution. Having said that, there is a piece that you download. It's a pretty big piece, too. It's a whole server component that you download that manages that for you, too. So it takes the capabilities of Azure Backup, gives you a central place to manage that and manage the multiple servers that you have out there. So it's a pretty robust system. Just understand what that is. What I have in green, I didn't bother putting a separate slide on there. Maybe I should have, just so it's easier to find in the deck. But disks for backup storage pull 1.5 times the size of the data to be protected. Okay, so if you've got a machine that's, let's say I have 500 gigabytes of storage that I need to back up, well, that means it's going to need 750 gigabytes to back it up because you're doing like incremental backups and stuff. So you're you are collecting multiple versions of the same file, so you have more additional restore points. So it's more than just 1x. It's 1.5x. So additional documentation, Azure Key Vault and Azure Backup. I also have some labs in here. Oh, sorry, third-party tools. This was actually on my test. So I assume there might still be on there. What are some other options for backing up into Azure? So we have AZ Copy. We have SQL Server Backup to Microsoft Azure. Veeam Backup, Net Backup, Veritas, Acronis, Commvault. There's a lot more. I don't think you need to learn all of those. Just recognize them. So hopefully on the test, if it comes up, you'll recognize, hey, I've seen that before. It's this, this, this. A lab on standing up backup, literally 10 minutes. You can back up your entire workstation to Azure. Well, not back it up, but schedule it so that it kicks off. And you can manually kick it off or kick it off on a schedule. Design a disaster recovery strategy. Whenever we talk about that, let's dig into a little bit of store simple architecture. It's kind of a new approach where you literally have those disks in your data center, and then you're treating that disk set like a local SAN, but that local SAN is a lot more than just the disks that are comprised of that local SAN, because it has the capability of understanding what type of data it is. Is it hot? Is it warm? Is it cold? And then for that cold data, why would we want cold data on a SAN anyway? Cold data, the definition of cold data is it's never used, right? So having that on expensive SAN disks doesn't make sense. So what it does is it pushes that to Azure, but it has that hyperlink capability or forward link capability. So if somebody tries to access it, they just download it on the fly and present it to the user. So it's a really awesome technology. It's also great for remote offices where you don't have a full infrastructure or whatever. You can just kind of drop it in, and you can use that as your central mechanism for managing and making sure that you have replication and stuff. I'm not going to dive into this as deep as I thought because of just time constraints. But some of the supported workloads, you see SQL, SharePoint, VMware, open source, Windows, and files, collaboration, archives, all kinds of stuff. Integrated data protection and DR. So it does give you the DR capabilities as well, and that is I have my Store Simple SAN on premises, but I also have that backed up real time, asynchronously to the cloud. So that in itself becomes your recovery point. And that image can then be downloaded to another data center. Like if you have another one of these Store Simple devices, you can have that replicated right down to there as well. So some really cool capabilities built into it. Snapshots. Store Simple uses iSCSI protocol to link to the data storage. You might see that on the exam. This means the storage that is in Azure is presented as local attached iSCSI volumes. Okay. Site recovery, primary site. This is kind of looking at the architecture of that. Exchange, CRM, IS, SQL, whatever your workloads are running on your primary site, and then you have a replica site. You do have certificate authorization across the two sites that allows kind of the magic to be able to happen. And I do have a lab on that as well, setting up Hyper-V virtual machines without VMM to use Azure site recovery with the Azure portal. So you might want to step through that because that will teach you a lot about all of this technology. Replicate virtual machines, replicate physical machines. You can do it. I've got a lab on it. That's actually a really good scenario if you want to take a full snapshot of your laptop and post it up as a recovery site on Azure. Really cool use case, individually, but obviously it's more designed for servers. Azure Automation. How are we doing on time? I have until 12:15. Okay, we're okay. We're doing much better. No, it's me. We're doing much better than we did in the last one, so good. So Azure Automation, a few things that I want to talk about here: Chef, Puppet, desired state configuration. The big thing I want to highlight on this slide is DevOps Enabler, right? These are, I assume everybody's heard of some of these technologies, or maybe even all of them. I'm going to go into a little bit more detail on each one of them. But they're all fully integrated with Azure, so you can actually select them right from the marketplace. And there's others too that are not included on the slide. And the reason why I didn't include them on the slide is I'm pretty certain they're not going to be on the exam, right? But you have things like Docker, Ansible, SaltStack, etc. And there's a ton of others that are building in that integration with Azure. So which to use? All can be used with Windows and Linux. Chef primary use cases are if you already have a Chef management infrastructure, or if your primary expertise is in managing Linux machines. If you already have a Puppet management infrastructure, obviously you might want to go with Puppet. Same thing. It's primary expertise in Puppet or in Linux machines. DSC is PowerShell based, so if you have a lot of expertise on PowerShell already, that's a great thing to get going in. If you do not already have a configuration management solution, DSC is a great starting point to get you started on that because it's very easy, very lightweight. If your primary experience is in managing Windows machines, that DSC will do Linux as well, but it's very easy if you have that Windows-based expertise already. Uses vendor-neutral configuration files, MOF files. DSC is one of the very few products on the market today that do that. So most of the others have proprietary, and Microsoft decided to go with the open framework for that. Azure Automation, if you do not already have configuration management or not deeply embedded, if you want significantly to expand your configuration management without significant expense, if you already own OMS, or you're going to use OMS, Azure Automation all the way. If you already have PowerShell expertise. So let's dig a little bit deeper into Chef versus Puppet. They're both cross-OS systems management automation and analytics tools. Puppet is probably a little bit more mature than Chef. They're both actually based on Ruby. The Chef side, it's Ruby and Get are required, plus an agent is installed on each of the machines. Good for development-focused teams, code-driven approach to configuration, stuff like that. You can leverage Chef inside of Azure. I pointed that out earlier. And Puppet, Chef has a pretty big catalog as well, but Puppet probably has like I said, it's more mature, so it has a bigger catalog.
All right, so we'll round this out with Azure Automation. Now, we do have labs for the OMS stuff that I spoke about. It will take 15 to 20 minutes to go through and set up OMS, a virtual machine, and configure it to do log analytics. We also have a lab for this, setting up Azure Automation. I went with the graphical interface because it's pretty cool to check out and write a script and using a GUI, essentially. So we went ahead and went with that route on the labs. But let's talk a little bit about Azure Automation. I've used Azure Automation quite a bit, and I think you should too as you're going through this, because you can schedule and set up different types of triggers to actually initiate the execution of a runbook, which gives you a lot of flexibility for what you want to do. Plus, typically, the API for something in Azure comes out first, then it gets integrated into the tooling as well as the portal. So it's API kind of first-driven development, and then we drop that into the portal, and then it gets added into the modules and the CLI. So with Azure Automation, essentially you create an Azure Automation account, and inside of that account you create runbooks. And runbooks are the concept of actually just a script and the assets that enable that script to run against Azure or the resources within Azure. So assets are things like the subscription, the way you would authenticate to the subscription using like a service principal or using a X509 certificate. Same thing if it's a Linux server and you're running against the Linux server and you need the SSH keys or something of that nature, you would add those assets into the automation account and then enable them in the runbook. You do need to be able to use the PowerShell module, which is installed as an asset by default. You can install other modules if you need them as assets within the runbook. And you can schedule jobs, essentially, and you can have also different webhooks and things so that you can start the runbook automatically. So know each kind of one of these portions of this. The lab walks you through it pretty easily and allows you to do that. Now, these webhooks are great for things that are coming out of OMS or coming out of System Center or coming out of just the Azure portal, because you can just send emails or you can call a webhook. And that webhook can actually point to a runbook and execute that. So you get an alert coming out of the portal, it can execute that runbook for you and do kind of that self-healing, that auto-healing of a service, which is a pretty awesome tool if you ask me. There is a gallery. You will see some stuff about the gallery, which is pretty nice. You just go right into the gallery and scroll through and find exactly what you need or something close to what you need, and then you can modify it, which is a very nice tool to have. PowerShell, there's also what's called PowerShell workflows. And PowerShell workflows are for long-running tasks. It allows you to hibernate a task for a certain amount of time or until something else happens, and then you can rehydrate that and continue running. You can also build in checkpoints so that you can script in retry logic, which when you're dealing with networks and things like that, you may lose connectivity or something, and you want to retry that on certain intervals. So that's a good one. Dan talked about DSC, so I'm not going to spend a whole lot of time on that. But there is a lab.
Actually, let me just say one more thing on that. We're both doing it, sorry. The DSC, the way that I look at DSC, or the way you should memorize or remember DSC, is it's a make it so language. So you're defining what the system should look like, i.e. it should have IIS installed, it should have this port open, it should have that port open. It should not have such and such installed, right? It's a make it so scenario. And so it's a constant configuration. Or it's also a great way to deploy additional capabilities on your web server, right? You want to add PHP capabilities to your IIS servers. Well, you're adding the capabilities to adding that piece of IIS into IIS by just saying make it so.
Yep. So again, take a look at the labs. They're short and sweet. Yes, question? With SCCM.
How does it what?
How does it integrate?
I don't know.
I mean, I imagine you can create a task in SCCM to execute that and essentially push it out and run it. But the DSC server architecture is separate from SCCM.
Yeah.
That you can schedule it to run so that you don't get configuration drift and whatnot.
I would think that what you're doing with that is you are setting up, configuring the type of node, right? So depending on how you're using SCCM, you're either making it, you want to make it match this. Well, that's kind of the job of SCCM. It can do that. So adding a task to, think of it, SCCM is you're making it so now, but if somebody changes that, that's not where SCCM comes in. Where DSC comes in is somebody makes a change, well, it's automatically going to put it back. Huh? Piece by piece, you can add up. Yes. So you can, but what that means is you're setting a node. If the node is a web server, then from SCCM you could say, I also want to add PHP, right? And that's going to, you can push that out to the server, but you could also push it out to your DSC system, or your monitor, so that it not only pushes it out now, but it keeps it there in the future. Yeah. So SCCM is a one-time push of whatever your configuration is. DSC is always make it so. If you haven't already pushed it out with System Center Configuration Manager, then it can also push it out.
I think that, yeah.
What is it running? So what applies?
It's PowerShell based. So you're
So you have two, you push it with a script, you can
Yep.
execute it with a script, or there is like a server architecture where you can configure it to pull down from the server to the node
based on time or whatever.
every 30 minutes, and it'll, the DSC subsystem will, basically PowerShell, will execute that and check the configuration, and if you do have drift, it'll put it back the way it should be, essentially. So it's kind of a pull scenario, I think.
Yeah, because you do have to wait for the server to check in.
Yeah.
So yeah, it does have to be that check-in, which
But
is
I
done
don't
on,
think-
on an interval. You can actually push it too, though.
Yeah.
Yeah, you can actually push it
Okay.
too.
Yeah, DSC is not my strong suit.
It's all PowerShell based, which is the beauty of it, because it's a different kind of PowerShell, though. The actual scripts themselves is not raw PowerShell if you look at it.
It's a declarative language.
It's a declarative
not
language.
scripting.
I actually had some shots on that, and I think I got rid of them.
Yeah.
So just to cut time, unfortunately. But those slides are going to be in the deck. So if you download it, you'll be able to kind of read through those other slides that we ended up having to cut out. And that was one of them.
Yep. And I think they cut a lot of the PowerShell from the test.
Right.
On this.
Which was one of the reasons when I went to cut my time down, I had 180 slides for a 75-minute presentation. So I cut a lot. And the first place I cut was like the backup where I had one slide with pictures. I had like 8 slides before. And then PowerShell, almost all of PowerShell was cut out because they've removed that core competency from this particular exam. Sorry?
There are a couple,
There
but
might be a couple.
it's a hit or miss if you get them or not.
It's not like whenever I took the exam, it was like half the test. Yeah. And whenever I took the exam, it was about half the
Yep.
exam. Yeah.
I had the same thing.
Automation use cases, monitoring configuration, eliminating configuration drift, automated change of configuration. You know, you want to maintain the exact configuration, override others, the same as drift, right? Somebody makes a change, I want to change it back. Automated testing, right? Desired state configuration is a great way to do automated testing. You can do auto start, auto stop. You know, automating your hybrid scenarios, right? There's lots of use cases for desired state configuration. My favorite, though, yours is probably automated deployment. Mine is, it might be close to implement DevOps practices as well. Desired state configuration is a great tool to push configuration changes that are dictated by DevOps processes. So as you get into the DevOps mindset and way of thinking and way of doing things, desired state configuration can be your execution arm to make it happen.
Yeah, I mean, in that one, just, I mean, you can get pretty.
Oh, this is the slide I thought I cut out.
Yeah.
So desired state configuration, the configurations are stored in Azure Automation. They can be directly applied to virtual machines. Other physical and virtual machines can request configuration, so that's your push and your pull. And the ports that you need to be concerned with for the exam are TCP 443. That's from from local to Azure. The TCP 5985 is, or 5986 are your hybrid runbook worker to local machines and resources. And notice that your hybrid runbook worker is running locally and manages local resources. So think of that as kind of your gateway for on-prem. So those are kind of the things. And I do have a link in here as well, so you can kind of read more about it and kind of see how it all works.
Cool.
We're done.
We're done.
We're done. Awesome. So now we have time for questions.
Yes. So it was on one of the slides as part of the OMS suite. So you can enable that through OMS as well and ship that data into OMS so that you get this one place to kind of, instead of going to the security center and then going over to Azure Automation, and you're jumping around in the portal a lot, you can just enable an OMS workspace and roll all of that up underneath it. ASC. Yes, it's new.
Oh, it wouldn't be on the exam anyway. I'm not sure. I don't know that answer.
So most of it
So
is log analytics. but
repeat
you
the
can
question. You're killing us.
So the
sorry for those people that are online. Really, really, my apologies.
the
We're
question
terrible.
was, ASC isn't part of the OMS. You can pull the data into it and report on it through OMS and alert on it and things of that nature without having to use the actual portal. But you're right, it is its own entity, but you can bring it in.
Think of it as like the logs, right? You're bringing in all that data.
Security Center was more geared towards the security talk, security portion of it. They covered it. I think Bill covered that pretty well.
Bill covered that.
Yeah, so.
So how are we doing on time? Because maybe we can break out into a demo or something. Or we could just go to labs. Why don't we go to labs?
I think labs is a good idea.
Yeah. Oh, well, I guess we got to go to labs anyway. So, or, you know what? A couple things, a couple announcements. So, thank you, Ethan, for all of your contributions on this. It was awesome. I said Ethan again. That's twice in 2 days I've called him Ethan. Oh, my God. Ian. And that's too much going on in my brain. My apologies again. Lunch. And I hope everybody that's online is still here as well, because we're changing the schedule for lunch. We mentioned it earlier today. For lunch, it is a lunch and learn. So instead of doing labs, we're going to actually have presentation. I've had a ton of questions about containers. So we're going to go a lot deeper into containers. It's not going to be on the exam. Well, not yet. Eventually it will be, I'm sure. But we're going to go a little bit deeper on containers during lunch. And we got a couple of other little things that we want to kind of, that we think are fun to discuss. We're going to do that during lunch. So lunch is open for here in New York. For those that are remote, please grab some lunch if you can and come back. If not, we will have the session recorded as well, so you can catch it online. But we're going to talk about containers, a little bit about DevOps and microservices, but more about containers. And so we're going to take like a 15-minute break to go grab our lunch, come back into the room, and we'll get started with that presentation. Okay, thanks.